tomorrow morning, we may have a glimpse at just how much water there might be frozen in the cold, dark craters of the south pole of the moon. There are even some scenarios where you'd have not only a mobile habitat, even a mobile lander. And under those scenarios, you could land in one place, travel, do science, explore different areas, go to different places of interest, and leave and remotely have your habitat or your lander move to the next spot for the arrival of the next crew of astronauts. So there have been some very clever ideas put forth to essentially lay out what can we do of value on the moon. So as one example scenario, what you're seeing here are linked habitat modules, solar arrays. This is one of the non-nuclear options. Some hexapods for moving things around. And again, we have some very clever roboticists out at JPL working on a mobility concept with 6 legs, wheels on them, which makes it very versatile. But bottom line here is this is way beyond Apollo. And this is a picture of some of the current work that's going on. This was a field demonstration out at Moses Lake, actually, in Washington last year, 2008, with, among other things, a brand new Chariot lunar rover where the astronauts are actually hooked into a support that allows them to stand. Lessons learned during Apollo was that when you're in that pressurized suit, it's actually difficult to bend over to sit. So it's actually more comfortable and much more natural just to stand and ride. You have, again, the all-terrain hex-limbed extraterrestrial explorer, or athlete for short, platforms. So you have a wide array of helpers for the astronauts. So at Johnson Space Center, the Human Robotic System project is headed up. One of the things that they've done is taken a feature-rich design approach. So this is already a year or two old, the picture, where, again, you see the heads-up display possibility, the harness or struts that you can clip the astronaut suit into. Notice that these wheels can be gimbaled in any direction, so you can crab to get out of the way of large rocks. It's a very versatile vehicle, which not all of those features may make it onto the moon, but here we're exploring what makes the exploration of the moon easier. Another version of this actually puts a habitat module on that chassis to, again, allow you to explore much greater areas once you're on the moon. The LRV during Apollo, the astronauts about 10 times the range that they could go on foot, with the proviso that they could not drive, could back from in case you had a breakdown. With this kind of a vehicle, you can live for quite a while. You're not limited by your suit resources, so that when under some of the scenarios you have 2 of these up there, you can range much farther, do science much farther from the landing site, because even if you do have a breakdown, the vehicle can come and everyone can one to get back to safety. It has a port, and as well there's kind of a canopy on back here. One of the other very clever features that they're thinking about in enhancing exploration of the moon is, you see this viewports down towards the lower front of the vehicle. When you put a geologist in a vehicle like this and he or she sees a rock that they're interested in, you'd like them to be able to get out and get at it. Well, what they are thinking about having on here is a suit port where the life support system of the astronaut suit actually clips into a ceiling ring. You climb into the suit from the back, close the hatch, latch your life support backpack, and take off. Shirt sleeve to surface in, well, ideally 15 minutes, but even if it's twice that long, that's much better than the hours that you currently have to take to get from the space station to spacewalking. So, and this is a picture from just last month at a field demonstration out in Flagstaff, Arizona. Back to the JPL All-Terrain Hex-Limbed Extraterrestrial Explorer, and I wrote it down because I wasn't sure that I would remember the acronym. Athlete is, again, an extremely versatile robot, basically, because it has so many degrees of freedom. And some of the really good work that they're doing now with this Earth analog is some of the control algorithms. You can take two of those wheels and grasp and lift something up. They have a module on there that allows you to attach a drill bit, an Earth auger, or a moon auger, I guess, and drill an anchor point. So these are very versatile robots, and also they allow you to very precisely match docking seals, so you can expand your habitat. The actual moon athlete will be huge. Again, because on the moon, you can. And you need that size in order to use these things, for instance, for offloading the lunar lander equipment. So, and as well, you have other helpers. One of the goals of the Human Robotic Systems project is to allow NASA to sustain operations between astronaut visits, so that you will have a work done without, between when humans are there to do some of the exploration. And this is just a mobile sensor platform for prospecting, for instance. And this guy, of course, can use the same tools as the astronauts. Now, I mentioned that the moon is a hostile environment, and I want to re-emphasize just how hostile that is. As Ferenc mentioned, you're dealing with hard vacuum, direct solar radiation, cosmic radiation, micrometeorite bombardment, extreme temperatures. Oh, and did I already say no air? Hard vacuum. Those wheels will not survive